In this video, we'll look at finding the area under the curve. And so we're going to look at a geometric way of finding the area. And so the first thing I want to point out is that the area under the curve is the area between the graph and the x-axis. So for a graph like y is equal to 4 minus x squared, the area is this area under the curve, between the curve and the x-axis. For a graph like y is equal to x squared, that area is the area between your graph and the x-axis. So it is the area under the curve. So typically what we're going to do, the geometric interpretation of this is we're going to divide that area into rectangles. There are other techniques where you could divide it into trapezoids or use another method to approximate. Essentially, we're approximating the top of the curve, the top of the graph, which is curvy. And so for this video, we'll use rectangles. If I wanted to find the area of the graph y equals 4 minus x squared from 0 to 2, which is here, if I want to use 4 rectangles, then I'm going to take 2 minus 0. Essentially, this is the area from A to B. So this would be B minus A. And then I'm going to divide it by the number of rectangles. So that gives me 2 over 4, or 1/2. And that distance here is the width of my rectangle. So in general, the width of the rectangle would be B minus A divided by N, where N is the number of rectangles. Now you have to make a choice in looking at these rectangles. Do we want to pick the left end point? So this is here. Or do we want to pick the right end point? Notice that if I draw my rectangles with the left end point, I'm going to overestimate by these red marks here the actual area. And if I use the right end point, it's going to be an underestimate of that value. And so then we're just going to recall the area of a rectangle is the width times the length. So my width is going to be 1/2. My length, the length will be the value of the function evaluated at that left or right endpoint. So that's going to be f of whatever value the left and right endpoint will be. And then we're going to sum all of those up. So we'll have 4 rectangles. The area, so for example, for the area for the left would be 1/2 times f of 0 plus 1/2 times f of 1/2 plus 1/2 times f of 1, and then plus 1/2 times f of 3/2. And so I can calculate that out, and that's going to give me 4.25. I'm sorry, it's going to give me 6.25 square units. So I can do the same thing with the right triangle. So this is using the left endpoint. For the right endpoint, the area is going to be 1/2 f of 1/2 plus 1/2 f of 1 plus 1/2 f of 3/2 plus 1/2 f of 2. And this is going to add up to 4.25 units. And so the idea here is that if we increase the number of rectangles, let me just draw my picture over again. If we increase the number of rectangles, then the width of each rectangle then the width gets smaller, and the difference between, let me just draw a picture of the function. The difference between whether you choose the left endpoint or the right endpoint is not going to make a difference. So because as we get smaller, this distance gets closer, and so it won't make a difference. So what we would have is we would use some arbitrary endpoint, some arbitrary point to represent the height or the length of the rectangle. And I'll get into that in the next video.